Okay, so question number 1 says a rectangular column of 200 mm wide and 100 mm thick. So there is one rectangular column the dimensions are given. This is 200 and this is 100. The dimensions are given in mm. Okay, so it carries a point load of 180 kilonewton. So it is carrying a load of 180 kilonewton at an eccentricity of 100 mm in the plane bisecting the thickness. Okay, so if you read the question properly, it is given as the 100 mm is the thickness, and in the second statement it is given that the point load is present on the axis bisecting the thickness. तो पहले आपण दोन्ही axis draw करू. This is the x axis and this is the y axis, आणि हा center point is the centroid. Okay, so now the load which is acting on this column is present on the x axis because it is bisecting the thickness 100 mm. ठीक आहे, तर हा जो arrow represent करतो आहे याच्यावर load आहे. At what distance is that load? It is at an eccentricity of 100 mm. So this distance will mark this point, and this distance is the eccentricity E. I hope this much is clear. Now this is the main axis passing through the centroid, and this is the axis of the actual load. The actual load is acting on this axis. The value of load is this P, आणि हे P ची व्हॅल्यू दिलेली आहे 180 kilonewton. So this is 180 kilonewton. So the dimensions are given, the value of load is given, eccentricity value is also given. Now we have to calculate the maximum and minimum stresses in the section. Maximum and minimum stresses in the section. So in the assignment, it is question number 2. First step is to write the given. So काय आहे given दिलेलं? Load P is equal to 180 kilonewton. Load P is equal to 180 kilonewton. Eccentricity E, the value is 100 mm. The value of eccentricity is 100 mm. Then the dimensions of rectangle is given, B and D. So B is 200 mm and D is 100 mm. Okay, so these are the given things. Now the next point is to find. काय काढायचं आहे आपल्याला या क्वेश्चन मध्ये. सो दोन गोष्टी काढायच्या आपल्याला. फर्स्ट आहे मॅक्सिमम स्ट्रेस. Maximum stress. Maximum stress. So we denote this by sigma max. Second thing is minimum stress. Minimum stress. आणि याला कशाने डिनोट करतो आपण? Sigma minimum. ठीक है? So these two things we have to find. Now whatever the formulas we know, we will write those formulas. So we know that maximum stress, so you should write the full form. Okay, maximum stress is equal to, what is the formula for maximum stress? Maximum stress is equal to direct stress direct stress plus bending stress. Direct stress plus bending stress. Okay, so this we can write it like this: maximum stress sigma max is equal to direct stress sigma naught or sigma 0 plus bending stress sigma b. So this is the first important equation. Next I have minimum stress चा formula. Minimum stress, what is the formula for minimum stress? Minimum stress is equal to direct stress minus direct stress minus बेंडिंग स्ट्रेस. मॅक्सिमम मध्ये प्लस असतो, मिनिमम मध्ये मायनस असतो. ठीक आहे, मायनस बेंडिंग स्ट्रेस. सो वी कॅन राइट इट लाइक दिस: सिग्मा मिनिमम is equal to direct stress sigma naught minus sigma b. These two are the very important formulas from this unit. Okay, this is equation number 2. हे सिग्मा मॅक्स आणि सिग्मा मिनस काढायचे आपल्याला. सो फर्स्ट वी विल फाइंड आउट इंडिव्हिज्युअली व्हॉट इज द व्हॅल्यू ऑफ सिग्मा नॉट. सिग्मा नॉट इज इक्वल टू फोर्स P divided by area. Direct stress is equal to force divided by area. What is the value of force P? 180 kilonewton. So 180 kilonewton आहे. ठीक आहे, so in as it is kilo म्हणजे 1000, so 10 to the power 3 divided by area. Now this area is the area of this cross section. Area of the cross section, whatever this area is there, area of rectangle, that we have to write it there. So area of rectangle is b into d. What is b? 200 and d is 100, so 200 into 100. So 200 into 100. So if you calculate this, you should get 9 Newton per mm square. 9 Newton per mm square. Similarly, bending stress sigma b can be written as my divided by I or m by z. Now this m is movement, that is force into distance, and that distance is eccentricity E. This y value, हे जे y value आहे, this y value is nothing but this value, b divided by 2, distance from centroid to the extreme fiber. So it is b divided by 2, that is 200 divided by 2. Now to decide whether to take Ixx or Iyy, we have to take the concept of bending axis, about which axis the bending is taking place. So the bending is taking place about y axis. Y axis च्या about जे आहे ते bending होत आहे. So we will have to take the Iyy value. Okay, substituting the values, P is 180 into 10 to the power 3. Eccentricity E is 100 mm, so 100. The value of B is 200 divided by 2, so this is 200 divided by 2. divided by Iyy. Okay, so to calculate Iyy, we will have to do 100, that is BD cube by 12, 100 into 200 cube divided by 12. 100 into 200 cube divided by 12. So if you solve this, you should get the answer as 27 Newton per mm square. 27 Newton per mm square. ठीक है, सिग्मा नॉट झालं, सिग्मा भी झालं. Now substituting the formulas in equation number 1 and equation number 2, sigma max, that is maximum stress, is equal to sigma naught plus sigma b. What is the value of sigma naught? 9. What is the value of sigma b? 27. 9 plus 27 is 36 Newton per mm square. So this is the value of maximum stress. Similarly, sigma minimum is equal to sigma naught minus sigma b. Sigma naught ची value आहे 9, sigma b value is 27. 9 minus 27 is minus 18. So this is minus 18 Newton per mm square. This is the final answer for this question. Okay, so given to find, then writing the formulas, substitute the formulas and get the final answer. Okay, so now we'll see the next question. So next question is also same. I'll read the question first. A rectangular pier 1000 into 1500 mm is subjected to compressive load of 500 kilonewton with an eccentricity of 250 mm bisecting the 1000 mm side. We have to calculate the maximum and minimum stress intensities. Same I have question. First we'll draw the diagram. So this is the column. In this question it is given as a pier. So pier is also a column which is having high diameters, or we can say a large size column. Now what are the dimensions of this? The dimensions which are given are 1000 and 1500 mm. So according to our diagram we are drawing it like this. This is 1500 mm and this is 1000 mm. You should write the dimensions when you are solving the problem. Okay, so these are the dimensions. Now drawing the axis, this is y axis and x axis, and the center point is the centroid of rectangle. Now it is given, question मध्ये दिलेला आहे की a compressive load of 500 kilonewton is acting at an eccentricity of 250 mm. आता त्या पॉइंट लोडची लोकेशन आपल्याला फाइंड आउट करायची आहे. त्यासाठी बघायचं की नेक्स्ट स्टेटमेंट काय आहे. इट इज प्रेझेंट अलॉंग द ऍक्सिस बायसेक्टिंग द 1000 mm साइड. बायसेक्टिंग द 1000 mm साइड म्हणजे हे 1000 mm साइड जे आहे, दिस 1000 mm साइड याला बायसेक्ट करत आहे. सो दिस इज द लाइन. सो आवर फोर्स इज प्रेझेंट on this line. Now what is the distance of our force? It is given as E is 250 mm. So this distance is the E and this is the location of the force. This is the location of the force. So this is the centroidal axis and this is the location of force P. फोर्स ची व्हॅल्यू आहे 500 किलोन्यूटन. 500 kilonewton. Okay, so now everything is clear. Now quickly start writing the given. So this is question number 3. Given P is equal to 500 kilonewton, E is equal to eccentricity is 250 mm, B is equal to 1500, and D is equal to 1000. So these are the given things. Now what we have to find? So you write down maximum stress sigma max. You write down it completely. Okay? Maximum stress sigma max and minimum stress sigma minimum. Now next is writing the formulas same as we did in the previous question. We know that त्यानंतर लिहायचं maximum stress sigma max is equal to direct stress plus bending stress, and त्याच्या खाली write it down like this: sigma max is equal to sigma naught plus sigma b. So this is equation number 1. Similarly, minimum stress is equal to sigma naught minus sigma b. त्याच्या खाली लिहा sigma minimum is equal to sigma naught minus sigma b. So now individually will calculate. Sigma naught is equal to force divided by area. Force is 500 kilonewton. So 500 into 10 to the power 3 divided by area is B into D, 1500 into 1000. 1500 into 1000 mm. So याला calculate जर केला आपण तो it should come 0.33 Newton per mm square. Now next is bending stress sigma b, my by I or m by z. M is P into E. Now in this case y is this distance, okay, that is b divided by 2. B is 1500 divided by 2. आता what to take, Ixx or Iyy in this case? Same, by using the bending axis concept. Bending axis concept जर वापरली, so we can say that it is bending about the axis is y axis. So this axis is there. So it is db cube by 12. db cube by 12. Substituting the formulas, P is 500 kilonewton. Value of E is 250. B is 1500 divided by 2 divided by db cube by 12. So D means 1000 into 1500 cube. This whole is divided by 12. So if you solve this, याला सॉल्व जर केलं तर आन्सर यायला पाहिजे 0.33 Newton per mm square. ठीक है. So both direct stress and bending stress are same. So sigma max value, substituting this in equation number 1, you should write here, substituting this in equation number 1 and 2, we will get sigma max is equal to sigma naught plus sigma b. सिग्मा नॉट ची व्हॅल्यू किती आहे 0.33 आणि सिग्मा बी ची पण व्हॅल्यू आहे 0.33. सो 0.33 प्लस 0.33 इज 0.66 न्यूटन पर mm square. Now next is sigma minimum. Sigma minimum formula we have derived. Sigma minimum sigma naught minus sigma b, that is 0.33 minus 0.33, that is 0. Okay, so finally what is the answer? जे काही आन्सर येतं आपलं ते आन्सर कसं एका ब्लॉक मध्ये जे आहे यू शुड प्रेझेंट लास्ट मध्ये, दॅट इज सिग्मा मॅक्स. इट इज 0.66 न्यूटन पर mm square. Sigma minimum is equal to 0. So this is the solution for the third problem. Okay, so now we'll start the fourth problem. Fourth problem is somewhat tricky, थोड़ा सा tricky है, so pay attention. So a column is given same, but in this case the column is, the shape of the column cross section is hollow rectangular column. कसा आहे? hollow आहे. So this is our normal rectangle and this is the hollow rectangular shape. Okay, so a short column of hollow rectangular section has external dimension 2.4 meter by 1.8 meter. So this larger dimension is 2.4 meter. The shorter dimension is 1.8 meter. You can also write this in mm also. ठीक है, 2400 mm or 1800 mm. Now these are the external dimensions. या external dimensions ला आपण capital मध्ये लिहू, capital B and capital D. ठीक आहे, म्हणजे जो बाहेरचा रेक्टँगल आहे त्याचे डायमेन्शन. आता आतमधला जो रेक्टँगल आहे त्याचे काय ठेवायचे मग? स्मॉल b and small d. Small b and small d. Now one more important thing is given, that is thickness is given. Thickness म्हणजे this distance is given. या दोन एरोज मधलं जे डिस्टन्स आहे, this distance is the thickness. तर बघा thickness वर पण आहे आणि इथून खालून पण येणार. So this is also the thickness. So if we know the thickness, we can find out the values of small b and small d. Okay, now what is the location of load? Location of load, so it is said it carries a vertical load of 500 kilonewton at an eccentricity of 30 mm from the geometric axis bisecting the longer side. आता longer side कोणती आहे? 2.4 मीटर. तर पहिले दोन्ही ऍक्सिस ड्रॉ केले. दिस इज x ऍक्सिस, दिस इज y ऍक्सिस. तर कोणत्या ऍक्सिस वर आहे प्रेझेंट आपलं लोड? इट इज ऑन प्रेझेंट ऑन द ऍक्सिस बायसेक्टिंग 2.4 मीटर. 2.4 मीटर बायसेक्ट कोणतं करत आहे? ही लाईन करत आहे. सो द लोड इज प्रेझेंट ऑन दिस लाईन. So it is present at some distance and that distance is E. Okay, so it is present at this distance. Now we'll start writing. So this is question number 4. Given काय काय दिलेलं आहे? What is the value of P? P is given as 500 kilonewton. P is given as 500 kilonewton. Then eccentricity is given, E is 30 mm. 30 mm. Capital B value. आता हे capital B काय आहे इथे डायग्राम मध्ये दाखवून द्यायचं. Okay, so that's why I have given it here. Capital B is given 2.4 meter. So we will convert it into mm. 2400 mm. 1 meter is equal to 1000 mm. D is equal to 1.8 meter, that is 1800 mm. Now small b, आतमधला जो रेक्टँगल आहे तो जो b जो डिस्टन्स आहे, that small b is equal to capital B minus 2 times the thickness. Capital B is 2400 minus 2 times the thickness. So we'll write the thickness also. Thickness दिली आहे question मध्ये. Thickness is 20 mm. So this is 20. So 2400 minus 40, that is equal to 2360. 2360 mm. 2360 mm. Similarly, small d is equal to capital D minus 2t. Capital D किती आहे 1800 minus 2 into 20, that is 40. 1800 minus 40 is 1760 mm. 1760 mm. आता इतकं सगळं जे आहे गिवन मध्ये आपल्याला दिलेलं आहे. व्हॉट इज द नेक्स्ट स्टेप? टू फाइंड. टू फाइंड मध्ये लिहत चला काय काय काढायचं आहे स्टेटमेंट. जसं मॅक्सिमम स्ट्रेस सिग्मा मॅक्स मी फर्स्ट क्वेश्चन मध्ये लिहिलं आहे, दॅट्स वाय आय एम नॉट रायटिंग. अँड मिनिमम स्ट्रेस सिग्मा मिनिमम. Okay, then again write down the same thing. We know that direct stress, maximum stress is equal to direct stress plus bending stress, आणि त्याच्या खाली लिहायचं सिग्मा मॅक्स is equal to sigma naught plus sigma b. नेक्स्ट स्टेटमेंट काय आहे मग? नेक्स्ट स्टेटमेंट इज minimum stress is equal to direct stress minus bending stress, and त्याच्या खाली sigma minimum is equal to sigma naught minus sigma b. Minimum stress is equal to sigma naught minus sigma b. Equation number 1, equation number 2. Now direct stress sigma naught, force divided by area of cross section. काय आहे force ची व्हॅल्यू? 500 kilonewton. 500 kilonewton. So that is 10 to the power 3. आता बघा हे हॉलो जेव्हा जेव्हा आलं तेव्हा थोडंसं जे आहे एरिया काढताना यू बी केअरफुल वेन एव्हर द हॉलो सेक्शन इज गिवन. आता हॉलो सेक्शनचा क्रॉस सेक्शनल एरिया म्हणजे वी विल हॅव टू सबट्रॅक्ट द आउटर एरिया मायनस इनर एरिया. आउटर एरिया मायनस इनर एरिया. That means the area in this case is equal to B into D, capital B into capital D minus small b into small d. Outer area minus inner area. So write down the same thing here also. Outer area किती है? Capital B is 2400, small or capital D is 1800. Capital B into capital D minus small b into small d. Small b ची व्हॅल्यू आहे 2360 multiplied by 1760. Okay, so now if you calculate this, you should get the answer as 3 Newton per mm square. 3 Newton per mm square. Next is bending stress, my divided by I. My divided by I. M म्हणजे P into E. P into E. Now in this case, the Y value will be capital D divided by 2. This distance. Capital D divided by 2. So capital D divided by 2. आता IXX घ्यायचं की IYY घ्यायचं? How to decide it? Same, by using the bending axis concept. So in this case the bending axis is XX axis according to our problem. Okay, बघा तुम्ही जर प्रॉब्लेमचं ओरिएंटेशन वेगळं ड्रॉ केलं तर इथे IXX च्या जागी IYY येऊ शकते. सो इट डिपेंड्स ऑन हाऊ यू ड्रॉ दिस. कोणी कोणी they can draw 1.8 here and 2.4 here, so then the IXX and IYY can change. Okay, now substituting the values, P is 500 into 10 to the power 3, eccentricity E is 30, multiplied by D divided by 2. D is capital D is 1800 divided by 2 नाउ द मोस्ट इम्पॉर्टंट इज आय एक्स एक्स. ठीक आहे, हा प्रॉब्लेमच जो आहे इट इज ओनली फॉर दिस कॅल्क्युलेशन ऑफ आय एक्स एक्स. So for hollow rectangular section, what is the value of Ixx in this case? Okay, so for that we should know what is the value of Ixx for normal rectangle. So what is the formula? BD cube by 12. ठीक है, BD cube by 12. But as there are two rectangles, दोन rectangles आहे म्हणून outer rectangle चा moment of inertia minus inner rectangle चा moment of inertia. So for outer rectangle we will use BD cube by 12. So capital B D cube by 12 minus small b D cube by 12. So this is the formula for Ixx. Okay, now substitute it here along with the values. Capital B value is 2400, D is 1800 divided by 12. So BD cube by 12 minus same BD cube by 12 but small b. So small b is 2360 into D cube 1760 cube divided by 12. Okay, so solve this. On solving this you should get the answer as 0.14 Newton per mm square. 0.14 Newton per mm square. Now substituting these values in equation number 1 and equation number 2, sigma max is equal to sigma naught plus sigma b. Sigma naught ची value is 3 and sigma b is 0.14. So 3 plus 0.14 is 3.14 Newton per mm square. Similarly, sigma minimum is equal to sigma naught minus sigma b, that is 3 minus 0.14, that is equal to 2.86 Newton per mm square. Okay, so these are the final values for this question. I hope it is clear. Okay, so the last question now, that is question number 5. Remaining questions we'll discuss in the next video. So a vertical column is given, or a column is given. Okay, so in this column, on this rectangular column, 300 mm wide and 200 mm thick. So this is 300, this is 200. An axial load of 180 kilonewton is given. An axial load of 180 kilonewton is given. आता axial load म्हणजे काय? Axial load means the load is acting at the axis of the column. So this is the axis of column. On this axis only a load is acting and the value of that load is 180 kilonewton. Okay, so it is given as 180 kilonewton. Now along with this axial load there is a clockwise movement of 2.8 kilonewton meter. आता ही जे गोष्ट आहे this is extra given on this question. So there is one movement which is given m directly and the value of this m is 2.8 kilonewton meter. 2.8 kilonewton meter. 2.8 kilonewton meter. Now the location of that load is on the plane bisecting the 200 mm. The location of the axial load was on the plane bisecting the 200 mm axis. So हे 200 mm axis आहे म्हणजे या axis वर आहे load तो. So to get the idea of eccentricity, this statement is given. So let's say this is the initial position of this point load. बघा हा 180 किलो न्यूटन जो आहे हा इथून शिफ्ट केलेला आहे इकडे. After shifting this, we have got the 180 kilonewton force along with the movement 2.8. But the original position was here, this distance. Okay. Now, so this is question number 5. So first write down the given things. What is given? P value is given 180 kilonewton. Directly M value is given, that is P into E, 2.8 kilonewton meter. Then given the value is P is equal to 300 mm and D is equal to 200 mm. Okay, so what we have to find? To find write down here maximum stress sigma max and minimum stress sigma minimum. Previous questions मध्ये लिहिलेला आहे, that's why I'm not writing here. Okay, the next step is, we know that maximum stress is equal to direct stress plus bending stress आणि त्याच्या खाली लिहा असं sigma max is equal to sigma naught plus sigma b. Similarly, minimum stress is direct stress minus bending stress, that is sigma naught minus sigma b. So this is equation number 1, equation number 2. So sigma naught value, direct stress ची value कशी काढायची? P divided by A. P divided by A. So value of P is 180 kilonewton. So 180 into 10 to the power 3 divided by area is 300 into 200. 300 into 200. So on calculating this, you should get the answer as 3 Newton per mm square. Okay, similarly sigma b, my by I. Okay, my by I. Now directly the value of m is given in the question, 2.8 kilonewton meter. आता सगळ्या व्हॅल्यूज आपण न्यूटन आणि mm मध्ये टाकतोय. सो कन्वर्ट दिस इनटू न्यूटन mm. So 2.8, instead of this kilo, write 10 to the power 3, and 1 meter is equal to 10 to the power 3 mm, 1000 mm. So again it will be 10 to the power 3 Newton mm. So that is 2.8 into 10 to the power 6 Newton mm. Okay, so now substitute here 2.8 into 10 to the power 6 into y value. So this is the value of y, that is b divided by 2. b divided by 2. So किती है b? 300 divided by 2. Now which value we should take, ixx or iyy? It is iyy. Okay, iyy. So directly formula लिहितो आता मी, that is 200 into 300 cube divided by 12. So on solving this, you should get the answer as 0.93 Newton per mm square. Okay, now substituting these values in equation number 1 and equation number 2, sigma max is equal to sigma naught plus sigma b. Sigma naught is 3 plus sigma b is 0.93, that is 3.93 Newton per mm square. Sigma minimum is equal to sigma naught minus sigma b, that is 3 minus 0.93. This is equal to 2.07 Newton per mm square. इतकं झाल्यावर खाली असं लिहायचं answer. Okay, whatever the question is given, at last you should write answer, and whatever the final values which were asked in the to find, हे to find मध्ये जे जे लिहिलं आहे तुम्ही हे डायरेक्टली इथे लिहायचं. sigma max 3.93 Newton per mm square and sigma minimum 2.07 Newton per mm square. Okay, and then highlight this. So these were the first 5 questions of the assignment. Okay, so remaining questions we'll discuss in the next video.